Hello everyone, my name is Zhang Yanling and I am an engineer at Huawei. Today, I'd like to introduce the results of our recent performance tests, which compare the remote direct memory access over Converged Ethernet (RoCE) storage network in Huawei's NOF Plus storage network solution with the traditional FC storage network. Key storage applications and high-performance requirements are mainly based on the FC network. As the transmission rate increases, storage media evolves from hard disk drives (HDDs) to all-flash storage. All-flash storage delivers a 100-fold improvement in read or write performance, and this has led to the evolution of storage protocols from the Serial Small Computer Systems Interface (SCSI) protocol to the High-Speed Parallel Non-Volatile Memory Express (NVMe) protocol. NVMe significantly improves the storage throughput performance inside the storage system and reduces transmission latency. This is where the NVMe over Fabric (NOF) storage network comes in. There are several Fabric technologies. However, storage vendors tend to prefer NVMe over RoCE, which has become the mainstream choice for NOF. Huawei launched its NOF Plus storage network solution, optimized for all-flash, which drastically improves performance, reliability, and ease of use compared with standard NOF. For example, a customer in the banking sector has a large number of FC networks on the live network and is in urgent need of upgrading the storage network. Consequently, they are looking for a network solution capable of replacing the legacy FC-SAN network in high-performance scenarios. Can Huawei's RoCE SAN, the NOF Plus storage network solution, meet these requirements? To determine the answers, let's examine the process and the results of our performance comparison test involving both RoCE SAN and FC-SAN. First, we need to set up a test environment based on this networking. There are 4 hosts in the test environment, and each is configured with one 25G RoCE NIC and one 32G FC NIC. The RoCE NIC has a port to connect to a CE switch, and the FC NIC has a port to connect to an FC switch. Switches are connected in cascading mode. Cascading bandwidth is much greater than the host access bandwidth, and the bandwidth for connecting to storage devices. Dorado 6000 V6 is used as the storage device, a mid-range option featuring 2 controllers. The first step is to perform a test in a non-congestion scenario. On the hosts, use a tool to simulate service traffic and set key model parameters to simulate OLTP or OLAP services. Set the OLTP traffic model to small IRO random read or write to simulate billing services. Set the OLAP traffic model to large IRO sequential access to simulate operation analysis services. After the test is complete, observe performance indicators such as the IOPS, bandwidth, and latency on the hosts to gauge the performance improvement of RoCE SAN compared with FC-SAN. According to the test data, RoCE SAN delivers 85% higher performance than FC-SAN in non-congestion scenarios. RoCE SAN outperforms FC-SAN because NVMe delivers higher performance than SCSI. Next is performance test. In the slow-drain scenario, use a tool to construct slow-drain traffic on the hosts. Hosts 1, 2, and 3 concurrently access port A of the storage device to simulate sequential writes with 256 kilobytes OLAP data blocks, causing congestion. Host 4 accesses port B of the storage device to simulate sequential writes with 256 kilobytes OLAP data blocks, and no congestion occurs. Observe the performance indicators, especially those of host 4. According to the test data, RoCE SEN improves the performance of affected services in the slow drain scenario of the FC network by 302%. NOF Plus supports congestion back pressure of independent queues and refined traffic control, greatly improving the IOPS of the affected host. FCSAN is based on the credit mechanism. In congestion scenarios, back pressure is performed on a per-port basis. As a result, non-congested links are affected, and the rate of the affected host is reduced. NOF Plus is based on the ECN mechanism. In congestion scenarios, back pressure is performed on the per-queue basis. Consequently, only packets in the congested queue are back pressured, and only the rate of the corresponding queue on the affected host is reduced. According to these comparison tests, RoCE offers significantly better performance than that of FC. As such, the customer in the banking sector chooses RoCE as the next generation storage network. Well, that's all for this episode of Test It, Believe It. Thanks for watching.